Okay, it's still on example 3, but this time looking at an alternative method. This is actually the way that the book goes through it on page 10 on the first solution that they give. Probably a bit easier way of looking at it, to be honest. Same question, I'm not going to go and read it again, but this time it's kind of looking at the question in terms of parts, right? You've got p to q is 4 to 5 and p plus 2q to 4q. Now, what a ratio means that you've got p is worth 4 parts and q is worth 5 parts. Okay, so what if p, you can see here, is worth 4 parts, you've really got 4 over here, plus, well, 2 lots of q. If q is worth 5 parts, what's 2 lots of q? 10. Sorry, what's 2 lots of 5? 10. So we've got 4 plus 10 on the left of the ratio. And then you've got 4 lots of q. Well, again, q is worth 5 parts. What's 4 times by 5? 20. There we go. So we get to 14 to 20, which is what we got on the last video, but just much quicker. And then you can just simplify this by halving your numbers, okay, which will give you 7 to 10. So really, actually, this is a much quicker way of doing it, isn't it, than the way that I went through it in my head. But I always think it's good, right? It's good to look at things in different ways because people will think through things in different ways. Clearly, this way in this question is far more efficient than my previous method, but I've shown you anyway, so you can. It's always good to have different ways of doing problems because the more understanding you have, if you see a new question, your brain can link it to previous knowledge that you've acquired. Yeah, and the more things you know, the more methods you know, it's always a useful thing to help answer new questions. Anyway, I'm rambling about teaching and learning theory. Irrelevant. This is the answer. Good stuff.